Okay, so we are going to go over 6.1. So we're now in something called modeling periodic behavior. So when I say the word periodic, when I say that word periodic, what do you guys think about? What word do you hear in there? Modeling periodic behavior. What word do you hear? Yeah, a repeat. Very good. So the word period, right? Okay, I know where all your brains are going. We're not thinking about that kind of period. We're talking about um like something that repeats. Okay. So a period of time. So for example, if you thought about this period, right? We're in period 3, right? All of our classes, period 3, look exactly the same. There's a start, I teach them stuff, and then there's an ending. And then it repeats every third period. Even if you take all of your periods together, because we work in a block schedule, we had first period earlier, third period next, fifth period next, seventh period next. Then on our next odd day, we're going to have that same exact pattern again. So it's going to definitely repeat. So when we talk about the words periodic behavior, we're looking at something that's going to repeat. Okay. And then you'll understand, like, what the heck is Ferris? Like, what are we doing? Why are we talking about Ferris? Okay. So it says, find the following trig ratios and angles for the given triangle. Can you guys give me some answers here? I need to make this smaller because this is gigantic. What answers did you get? I know, right? Ferris wheel's very good. I know you're peeking over here, right? That's a Ferris wheel. All right. So sine of A. How did you find sine of A? Sine of A. Very good. Sine of A is 4/5. Why is it 4/5, someone? You're very good. Someone says opposite over hypotenuse. If you don't remember SOHCAHTOA, go watch some videos on that. I promise you. It'll pay off in this section. Okay, cosine, move on. Cosine, what's cosine? Very good, 3/5. Fantastic. Tangent of A, 4/3. I agree. I'm going to change colors for my B's. Sine of B, very good, 3/5. Hey, that looks familiar. Does any look familiar? I feel like you guys told me 3/5 before. I don't know, maybe not. Cosine of B. Cosine of B. Very good, 4/5. Last but not least, tangent of B, 3/4. So you should look at the similarities. Sometimes we talk about what's that word? Symmetry. This word of symmetry. So like sine of A over here is the same as cosine of B over here, which totally makes sense. If you think about that, this guy's opposite, this guy's opposite is this guy's adjacent. So it should be the same, right? Similarly, this guy's adjacent is this guy's opposite. That makes sense, right? Right? What you should be looking for is patterns and why they make sense. Then what they wanted you to do is find angle A and angle B. I'm pulling over my calculator. You should know why. How do I find angle A and angle B? What are they asking me to do when they're asking me to find angle A and angle B? No, not law of sines this time. They just want you to take this equation and do what with it? Solve for A, right? This is an equation. How many variables does it have? 1, A, right? So then here's my classic question. How do I get A out of sine? How do I get A from out of sine? Hopefully I've asked this question to you enough that whenever you see this, you're like, oh, I got to take the sine inverse, Miss Johnson. I got to take the sine inverse. I say the questions over and over again so your brain remembers this, right? So while you're taking the test and you're like, oh my gosh, A, why are you inside sine? Oh, wait, Miss Johnson would always ask me this. How do you get A out of sine? So if you're answering my questions over and over again, not necessarily in chat or out loud, but if you're answering my questions over and over again, this is going to be very familiar to you. Okay, here we go. So how do you get it out? So I'm going to use this equation. You can use any equation you want. I don't know. You guys all know that I like sine better, so I'm going to use him. So sine of A equals to 4/5. You guys told me, oh, Miss Johnson, just take the inverse of both sides. The what inverse? The what inverse? Very good. The sine inverse, right? Okay, so I scooted them over because now that I know that I was going to do that, I'm going to write sine inverse here, and I'm going to put him in parentheses because that's how I'm going to see him on Desmos, okay? So I go over to Desmos and I say, hey, Desmos, I need sine inverse. For those of you who don't know how to type this into Desmos, it's sine Shift 6 gets everything to be a superscript like an exponent. This is not an exponent. This is an inverse. And then now I'm going to hit parentheses and then I hit 4/5. This should look exactly the same. This is why I like Desmos so much and not so much the TI calculators. Because when I plug this into my TI calculator, it doesn't look like how I see it. Okay. This answer is wrong. But Ms. Johnson, you plugged it in right. Who knows why this answer is wrong? Why is this wrong? What did I do wrong? Yeah, very good. Do you see how I keep asking the same questions? Do you see how I keep asking the same questions? Ms. Johnson, is it because you're old and you forget? No, no. It's because you're young and I need to put it inside your brain. Okay, so my answer is going to be, I'm just going to leave it at 53 degrees right here, right? 53 degrees. So that therefore A is about 53 degrees. I'm just going to make it simple just for today. So this is 53 degrees. And I'm like, oh my gosh, Miss Johnson, are you going to make me do that for B too? Everyone says, you can. You don't have to. You can. You can do the same thing for B. Absolutely. Right? Yeah, same thing. Okay, someone just said, yay, I used a lot of signs on it and I got the same thing. Perfect. This brings me to the fact that when you're verifying your answer, you got to use a different way to do it. Some of your different way is going to be using like tangent, or you're going to find like one of these. Perfect. Okay, so in order for me to find B, yes, you can do the same thing. You could use cosine, you can use sine, you can use tangent of B. You could even use the law of sines. You could use the law of cosines, whatever you want to use. Probably the most efficient way to do it, very good, someone said it in the chat, is just from subtracting. So 180 degrees, the whole triangle, minus each of the angles, okay? Each of the angles, okay? I want to make this clear. In math, you can only add and subtract things that make sense, right? So some people, let's see, let's pretend I had a wallet full of money. Okay, how much money do you have, Ms. Johnson? Just pretend it's a wallet full. I'm going to say W, okay? And then I found a $20 bill in my pocket, right? Everybody good? I found a $20 bill in my pocket. How much money do I now have? Some people think that I have 20W. Now, that doesn't make sense because that literally means that I have 20 wallets. I don't have 20 wallets. I think I have 2. I have a wallet that I use and then I have a backup. Yes, the answer is 20 plus W. Why? Because it's how much money I have in my wallet plus the $20. It is not 20W. When you're adding things together, you have to add or subtract things that are alike. For example, if I had $40, everybody good? I have $40. And then for some reason, I lost my phone. I do not have $39. $40 minus one phone does not equal to 39. So some of you are like, what the heck are you talking about, Ms. Johnson? Well, when I subtract 180 degrees, I'm only talking about angles. So I'm not going to touch 3 because 3 is a side. I'm not touching 4 because 4 is a side. I'm not touching 5. Some of you are like, Ms. Johnson, that's obvious. Not really. I want to make sure that it's super plain to everybody. So I'm going to subtract all these angles. What is this number? What number is that? Very good. It's 90. So minus 90 minus 53, which I just found, is 37. So B is about 37 degrees. Questions on this? Okay. At this point, this question should be on a scale from 1 to 5. This question should be at about a 2. So if I had a rating for my tests, there are questions that are 1s, 2s, 3s, 4s, and probably like 1, 5. Okay. This problem is probably about a 2. You should probably see 2 or 3 of these types of problems on a test. So if you don't understand this problem, go back and watch this again so that you ace this part of your test. Does that make sense? How would you grade this test, Ms. Johnson? Well, there's not a lot of work for this here, so I would just grade it as though I saw it, right? Some of you are going to write me a note and say, so katoa. Like one of you said, yeah, I use the law of sines. In your work, I would see law of sines, so I don't really need any explanation here. Okay. All right, let's move on. I answered A and B. So today you'll be able to apply right triangle trig to a circular context, hence our Ferris wheel. Your question you'll be able to answer is, how can right triangle trig be applied to find how far points on a circle are away from a horizontal diameter of the circle? What? Okay, let's break this down. How can right triangle trigonometry? This is right triangle trigonometry. Why is it right triangle? Okay, this is a right triangle. Trig means sine, cosine, and tangent. Okay, whenever they say trig, well, actually, I'll be honest with you. Whenever they say trigonometry, they're referring to triangles. Okay, but when they say right triangle trigonometry, they mean sine, cosine, and tangent. How can you use right triangles? Do you guys all see right triangles in here? Not yet, right? Do you see triangles in here? Good. Take those triangles and draw altitudes. Okay, do you guys all see my altitudes now? Here, I'll make an altitude. From B to this line, do you guys all see my right triangle now? Yeah. So I like making triangles with my horizontal diameter here. I pretend that everybody's on an elevator and they have to go down or up to get to this floor. Does that make sense? So whenever I draw an altitude, my altitude is always going to be, well, I really like, this is Miss Johnson's preference. I really like it to go to the horizontal, right? And later on, this will be the x-axis, right? Okay. So you want me to find a right triangle in here. So some of you should see the right triangle now, right? How are you going to use that to the points that are away from a horizontal diameter? Just like I said, draw a altitude. All right, here we go. So perhaps you have enjoyed riding on a Ferris wheel. Anybody ride on? Did anybody ride on the Disney one? That was my favorite one. The movie ones, yeah, like me screaming, very funny. Okay, the Ferris wheel was invented by George Washington Ferris for 1893 Chicago World's Fair. This is not your first president. This is not your first president. This is Ferris, hence the name of the Ferris wheel, right? So Carlos, Clarita, and their friends are celebrating the end of the school year at a local amusement park. Carlos has always been afraid of heights, but today he has chosen to ride on the amusement park Ferris wheel with his friends. As Carlos waits nervously in line, he has been able to gather some information about the wheel. Okay, legit, this is how Miss Johnson is. Like, she thinks about math whenever she's around. Okay. By asking the right operator, he found out that the Ferris wheel has a radius of 25 feet. What's a radius again? Remind me what a radius is. You did. You're very good. Center to circle. Very good. Center to circle. Center to circle. Good. And its center is 30 feet above the ground. What's 30 feet above the ground? This center is 30 feet above the ground. Does everybody see that? Good, very good. 30 feet above the ground. With this information, Carlos is trying to figure out how high he will be at different points on the wheel. How high above the ground will Carlos be when he's at the top of the wheel? To make things easier, think of his location as a point on the circumference of the wheel's circular path. Okay, so I'm going to use this gigantic circle over here because I have it and I want to use it. The first question is, how far is Carlos above ground when he's at the highest point? So we don't even have a point right there, but just imagine this guy right here. I want you to figure out how you would figure out how high he is from the ground. We're pretending this guy down here is the ground. Okay, does everybody see that? So we have all of this, all of this. I can't even draw a straight line with my mouse. All of this. Good. I'm going to give you a couple seconds to figure this out while we do that. If you're stuck, don't do the waiting thing. I'm just going to wait for someone else to answer. Don't do that. Like legit be like, ooh, it has to be something. So you have the measurements in front of you. I believe they said the radius of the circle is 25. And then the height above ground for the center of the circle is 30 feet. Was it feet? Can someone verify for me? Feet? Was that feet? Okay, some of you are done. Love it. Love it. Love it. Okay, 2 more seconds, y'all. 2 more seconds. Get an answer in there. Even if you think it's wrong, who cares? Be wrong. Because what your brain will do as soon as you put an answer in and I write out the answer, you're going to go, I am wrong. Oh, shoot. I need to add you. Yes, don't worry about that. Just go with Desmos for now, hon. All right. So a bunch of people put their answer in the chat. Someone said 55 feet. 55 feet. Where'd they get 55 from? Very good. Someone says, I will put this in the. Hold on. I got to cut this because it's just easier for me to grab your answers. Where's my little thing? Hold on. I'm looking for my little snipping tool. So someone says, hey, Ms. Johnson, all I did is I added 25 plus 30 is 55 because you add the radius plus the 30 feet above the ground, and that's how I got my answer. So let me put that over here. I'm actually going to draw it so that you guys can see it. This is what your classmate said. Really? Oh, there it goes. Here's your classmate's answer. So the way I draw this, and please don't laugh at my really amazing drawing skills, is, where'd it go? Here it is. So here, is 25 feet. And here is my 30 feet. Is that okay? Everybody comfortable with that? Done. Okay. So be okay with looking at the numbers and being like, I wonder what that means. Okay. How high will he be when he's at the bottom of the wheel? How high will he be when he's at the bottom of the wheel? So down here, how high will he be? And then go ahead and put your answer in the chat. Go ahead and put your answer in the chat. I'm just copying because that's just easier for me to do. Yeah, very good. Someone says 30 minus 25, Miss Johnson. Exactly. Yeah. And convince yourself, like, why does that answer make sense? It makes sense because blah, blah, blah. Remember, we talked about arguing. When you're making an argument, it's even better, I'll say, when you argue with yourself to convince you that you're right. That's what I do during my tests. Like, am I really sure that this is right? So 30 minus 25 completely makes sense to me because if this guy right here is 30 feet and I cut the radius off here, because this is where he'll be, this little, imagine a little bubble right here. Yeah, you're left with 5 feet, right? Very good. Okay, let's move on. So we haven't gotten into right triangle trig, so we're about to. How high will he be when he is at the position furthest to the left or to the right? So we're thinking about F or A. Okay, F or A. So here, right, this one should make sense to you. This one should make sense to you. We're about to get into all the other points, meaning B, C, D, E, F, G, H, I, J. Okay. So we're going to do one together and then you guys are going to try to get the rest of them done. Okay. So, you guys, did you all come up with this one left or right? How high was he? Yeah, 30 feet. Very good. A and F are both 30 feet. So go ahead and fill out A and F right here at 30 feet. Right? because I want you already to have those answers in. 30 feet. Why, Miss Johnson? Because that's the same height as the center of the wheel. So then that would be 30 feet. So very good. I'm going to write 30 feet here so you guys have the answer. We don't need an explanation there, I don't think. So this is where we're going to spend a lot of time. Okay, a lot of time. It says, because the wheel has 10 spokes, Carlos wonders if he can determine the height of the positions at the ends of each of the spokes as shown in the diagram. Carlos just finished studying the right triangle trig and wonders if that can help him. Obviously, it's going to help you, Carlos. Okay, so find the height of the each of the points labeled A through J on the Ferris wheel. Represent your work on the diagram so it is apparent to others how you calculated each height of the point. Okay, so the very first thing that you're going to have to do is I'm going to go over here, is you're going to draw right triangles on here. So the very first thing I'm going to do, I'm going to find B. I'm going to take B and I'm going to drop or take him on an elevator ride directly down to this line here. The moment that I do that, what did I just create? What did I just create? Yeah, I created a right triangle. And then we say yay. We say yay because we have lots of opportunity, right? We have Pythagorean theorem. We have sine, cosine, and tangent, right? But you're like, Miss Johnson, I don't know anything about this triangle. You do. What do you know about this triangle? And actually, this needs to go all the way over here. Okay, let me label. I'm going to blow this triangle up over here. What is happening with my pen? My pen is being weird. I think I need to do an update or something. So I'm pretending that this is that triangle. What do you know about this triangle? 25 feet would be the hypotenuse. What? How would you know that that's 25 feet? How did you know that this is 25 feet? You're right. You're right on that. Yeah, it's the radius. Very good. So this guy here is the radius. So this is going to be 25 feet. I don't know this side. I don't know this side. Is this triangle solvable right now? Is this triangle solvable right now? No. I need one more piece of information. I don't know this. I don't know this. Hey, Miss Johnson, doesn't it kind of look like a 30, 60, 90? Can I pretend that it's a 30, 60, 90? Everyone say no. Say no. Say no. Okay, good. No. Why not? Because in math, you can't just say like, hey, it looks like it, right? Right. So does anybody see anything else that would help me find? Now you're right. I do need an angle. I do need an angle. In fact, I'm going to be finding this angle right here. Where? Oh, this angle's right here. Does anybody see a way that I can find this angle here? This angle here. Yeah, it's a piece. Like, do you guys all see this as pi? Right. Someone said it's like a piece of 360. Wait. Oh, he did? Yes. That's correct. Oh, he did say that. Sorry, my chat is not working so nicely. So someone said in the chat, and I'm going to paste it because you all see it. The interweb does not see it yet. Give me a second to bring our interweb friends up to date. Oh no, I lost some of it. Give me a second. Okay. This is what your classmate said. The angle of the far left, this guy here, would be 36 degrees because what? 360 divided by 10 pieces. Where's the 10 pieces? What is he talking about? Okay, I'm asking questions because I already know the answer. This is exactly what you're supposed to do. So if you didn't see that, then you're good. Okay. Just look for the 10 pieces that he's talking about. He's like, there's 10 pieces right here, Miss Johnson. Do you guys all see the 10 pieces? Yeah, the 10 pieces of pie. Does everybody see this as pie? Sorry, I switched the Ferris wheel to a pie. Does everybody see my pie? Good. So if you have 10 pieces and you equally divide them, you can assume a couple of things here, right? When they build Ferris wheels, right? They build them so that these are all like the same distance away from each other. So you can assume that these angles are all equivalent, congruent. Everybody okay with that? So your classmate said 360 divided by 10. That's perfect. So this guy's 36. Now is it solvable? Yeah. I don't need to solve the whole thing. Last chapter, we would solve the whole thing. We don't need the whole thing. What other piece of information am I going to look at for this? What other thing do I need to look at? Yeah. Yeah, I'm looking for this side. Very good. So I'm going to call this side, I don't know. I'm going to call him little b because that's what he's attached to right now for my big B. So could you find little b? Are you able now to find little b? Yeah, everyone says yeah. Now some of you for some reason like love the law of sines. I need you to step away from the law of sines for right triangle trig because it's a little bit more efficient. Is that true? Is that absolutely true? You can use law of sines. But I want you to be more comfortable in the SOHCAHTOA. Someone said no. Okay, so which one would you use SOHCAHTOA for this one? SOHCAHTOA. So I would encourage you all, for those of you who really, really like the law of sines, use that as your check, right? Yeah, I would use sine here. Very good. So I've got sine of 36 degrees equals to b over 25. So b equals to 25 sine 36, right? So then I bring over my calculator. He's already in degree mode, so we're good. So I got 25 sine 36. So there's my answer. I'm going to go with 14.69. Okay, so that doesn't really tell me the answer that they want. They want to know, down here, they want to know how high B is. Does that help you find how high B is? Yeah, right? Because if I know this distance and I know this distance, right? So can you tell me what B would be? I should write in A. You guys already told me this is 30 feet. Something's happening. And this one's 30 feet. Okay, and then B now, I believe, is going to be 30 plus, what was that, 14.94? Something's happening with my pen. It's kind of annoying me. 14, there it goes, 0.94. So that's about 44.94. All those weird lines that keep showing up, I don't know. It's kind of funny. So feet, and then you're done. All right. So here's where we're going to end. Your job is to find the rest of these. Your job is to find the rest of these.